Right, so we're going to keep using this ordinary annuity formula. It's our only formula we have for this section. It's nasty enough. We only need the one. And so what I want you guys to do is try 3A right here. If you want to give 3B a shot, you can. But go ahead and try 3A. And just so you know if you're getting the answer right. I know some people don't like to wait for me to tell them. I'll go ahead and put the answer up here at the top. So go ahead and hit pause and see if you can get this, and then we'll go over it. All right, coming back from our pause, we're going to invest that $400 each quarter. So that's how much I'm going to invest in. Got my big bracket right here. My interest rate, divided compounded quarterly. Now we have to do a little bit of work here. We want to know when she reaches age 60, but right now she's at age 40. So 60 minus 40 means we have 20 years we can invest. So I'm going to put times 20 there, and then minus that 1 all over. And again, I wrote too big on this. Let me see. I keep writing bigger than I really should. All right, so this is going to give me 400. And in my brackets, my numerator and my denominator. Oops. So many decimal places. I'm going to type that entire thing in to get my answer. $51,458.67. All right, now part B, I'm going to continue on using this. After age 60, Allison's not going to make any other deposits because she's not working anymore, so she's not getting that paycheck. So she's retired, so she's not going to make any other deposits. So now, instead of doing 5-3, that ordinary annuity, this is going to become the compound interest problem from 5-2. So just to remind you, it's going to become, we're going to use this formula right here now because we're just making a one-time deposit of the $51,000. So we're going to be using our compound interest formula. Remember, I would totally have that sheet, that formula sheet with you for the test. If you picked up the notes packet outside my office, or just print that one out to have a copy of that sheet with you so you can keep straight all these different formulas. The reason I'm switching again is because I'm not depositing each quarter now. Instead, I'm just going to take this one lump sum. That's going to be my principal. My interest rate's going to stay the same. And now we're just compounding quarterly. So my interest, I'm still growing interest. And we're going from age 60 to 65. So that's 5 years. Now this one we can actually type in all at the same time if we wanted to. This one's a little bit easier on the calculator. I'll just leave that on there for now. So we can type this all in at one time, and that means at the end, rounding to 2 decimal places, the end of that time she would have $64,361.96. All right, last example from this section, we'll look at example 4. I'm going to let you guys try this one as well, but I'm going to tell you it's like example 2 up here. This example 2 that we worked here. We're going to be time traveling, as I say it. We want to buy that car in 4 years. So I want you to go ahead and hit pause and give that one a shot. Coming back from the pause, I'm going to have to scroll up a little bit on this. We want $20,000 4 years from now. My interest rate is 2% and it's compounded monthly. And we want that in 4 years. So this is the one where I've got to do a little bit of algebra. I'm going to type in my numerator. Whole bunches of 6s. I know some calculators go out more than others on that one. That's okay. It's going to be all right either way. If I type both those decimals in, I'm going to get 49. And again, yours might be off a little bit at the end because of all those sixes. That's okay. And I'm going to divide both sides by 49. So that tells me each month I need to deposit $457. If I do that at the end of 4 years, I'll have the $20,000 that I need to buy the car.